All right, number 4 says if a sample proportion is 63, which of the following could be a 90% confidence interval? And so the interval will change based on the margin of error, but one thing will be true. The distance from this number to the left is the same as going to be the area from that number to the right. So if we have 0.63 in the middle, we would add some number, and that would give us our right endpoint. So we'd have 0.63 plus that margin of error, and then we would have 0.63 minus that margin of error. So the distance from the middle, from here to here, will be the same as the distance from here to here, even though I've drawn it bigger. So if I have to subtract 2, then I'll be adding 2. So that's the big characteristic that we're going to be looking for with this problem. So if I look at A, and they want you to select all that apply. If I started at 63 and I went to 69, that would add 0.06. So if I was to subtract 6 from 0.63, I would get 57. So this would not work. It's not the same on both sides. If I go with this interval and 63 up to 71, that means we would add 8. If I were to subtract 8, I would not get to 47. Here, if I add 8 and subtract 8, this one works. On this one, 63 doesn't even fall in between these two numbers. And then on this one, if we added 5 and subtracted 5, this one would work when you do that mental math. So C and D are the ones that work. Number 5, we want to compute the critical value that corresponds to 87% level of confidence. Okay, so what we're looking at when we do this one, level of confidence, we're told basically that we're looking for these two values so that 87% is in the middle. So what we're looking at is that 80% is the middle of this section. So if I take 100, basically 100%, subtract 87, that's going to leave me with 13%. Now as a decimal, that's just 0.13. So that 0.13 is divided up into two sections because I have this and this. 0.13 is actually what we call alpha. So we're dividing this by 2, so that's the notation that you see, the Z alpha divided by 2. That's just saying take that critical value divided by 2, you're going to get 2 different points, one on the negative, one on the positive. So 0.13 divided by 2, that's going to give us 0.065. So the area to the left is 0.065. If I were to add 0.065 to this, I can find out what that percentage is, and I can look for that percentage. But we're going to work backwards. We're going to try to find this percentage in the table, 0.065. And we can use technology if you need to confirm that. 0.13 divided by 2. We'll get to 0.065. So I'm going to be looking in the left table, the negative, looking in the middle for 0.065 or the closest thing to it, 0.0655. Okay, so I got 0.0655 and I got 0.0643. This one is 7 tenths, 100,000s, 10,000s below, so 0.7 would get me there. This one is 5 10,000ths above, so this one is closer. So this is negative 1.51, negative 1.51. So this Z alpha is negative 1.51, which will be the same on the other side. It'll be a positive 1.51, following the properties of symmetry. So this is how we find that critical value. And so we are asked to round the two decimal places, so we're just looking at 1